Good morning, everyone. Today I will teach you on how to solve exponential equations. So let's go straight to the examples. Here, what we have is 5 raised to 3x minus 1 equals 5 raised to 7x plus 23. So the first thing you need to look at in an exponential equation are the bases. So we need to make sure that the bases are the same, or that's the objective. That's the first thing you need to look at. Now here the bases are the same, they're both 5. So all we need to do here is to disregard that number 5 and solve for x of the exponents that are in algebraic expressions. So we have 3x minus 1 equals 7x plus 23. All right, so this is simple. Let's subtract 3x on both sides first. That will give us negative 1 equals 4x plus 23. And then let's subtract 23 on both sides. This will be 4x and then negative 24. And finally divided by 4 on both sides. So x equals negative 6. So that is the first thing you need to look at, the bases. If the bases are the same, then we can just disregard them and then create an equation based from the exponents and then solve for x. Now, what if the bases are not the same? For example, here we have 4 raised to 3x plus 5 equals 16x raised to x plus 5. You need to express either 4, 16, or both into exponential form in such a way that the bases will be the same. So say, for example, here, I know you're thinking 4 can be equal to 2 squared. And then 16 is the same as 2 raised to 4, right? Now, we can actually consider 2 squared and then 2 raised to 4, but it's better if we express the numbers 4 and 16 that with the highest base, and that is 4 for 4 raised to 1, and then for the 16 is 4 squared, right? So which means that I will not change this one, but I will change the 16, and 16 is 4 squared. Okay, so here what we did is we expressed one number in exponential form in such a way that the base is similar to the base of the other expression. So now we can disregard the bases 4 and equate the two exponents. Like that, and then let's solve for x. So here we have parentheses, which means we need to distribute that 2. So 2x plus 10. 2 times x is 2x, 2 times 5 is 10. And then 3x plus 5. Okay, so I will subtract 2x on both sides first. Plus 5 equals 10, and then that's number 10. And then subtract 5 on both sides. So x equals positive 5. So that's one possibility. You are going to express one number into exponential form in such a way that the base is the same as the other base of the other side of the equation. Now, another possibility that you might encounter is this. So you cannot express 243 with a base of 81. Also, you cannot express 81 with a base of 243. So what we will do here is to find that common base. So you're thinking 81 is 9 squared, but 9 raised to what equals 243? Right, you cannot 3 with a base of 9. But let's say 3. 3 raised to what equals 81? That is correct. 3 raised to 4, right? 3 raised to 4 equals 81. So this is 3 raised to 4, then x plus 2. Now what about 243? Well, that's 3 raised to 5. So this is 3 raised to 5 times 3x minus 5. Now, since we have the same basis right now on both sides of the equation, we can disregard those two 3's and solve for x. So this is 5 times 3x minus 5 equals 4 times x plus 2. So let's distribute the 5 here on this side of the equation. This is 15x minus 25. This is 4x plus 8. Okay? Now let's deal with the terms that have a variable first. So negative 4x, subtract 4x on both sides. This will be 11x minus 25 equals 8. Then let's add 25 on both sides. This is 11x equals 33. And divided by 11 on both sides. So x equals positive 3. So there you go. That's how you solve exponential equation.